Alright, this will be our second video in the lesson about solving quadratic inequalities. Alright, we'll be solving this by factoring. Alright, the first thing we need to do is find the x-intercepts of this parabola, the zeros of this function if it were an equation. Okay, so what I'm going to do is pretend instead of being greater than this, that this was x minus 3 equals 2x. Alright, let's just solve this equation. That'll tell us where the x-intercepts of the parabola are. So, I would subtract 2x from both sides, okay, to get this all on one side. So that would give me x squared minus 2x minus 3 is equal to 0. Then I would want to factor this. So, this will factor as a binomial times a binomial. So x squared is just x times x. 3 can only factor as 3 times 1. Inner plus outer equals middle, right guys? So inner, I've got 3x, and outer, I've got 1x. Okay, so 3x and 1x. I'm trying to get a middle of negative 2x. That will happen if I have a negative 3 and a positive 1. So there's my negative 3 and there's my positive 1. Then I have to check, am I getting a negative 3 out of this? Sure, negative 3 times positive 1 is negative 3. So we have factored it correctly. Alright, now, so to find the zeros of the function, we have to set these equal to 0 and solve. So just adding 3 on both sides, I get x equals 3, and subtracting 1 on both sides, I get x equals negative 1. Okay, so these are the x-intercepts of the graph, 3 and negative 1. So let's go ahead and graph these on the number line. Okay, 3 and negative 1. So let's see. Always include 0 on your graph. Okay, so negative 1 we could put, like, let's say here, and 3 would be about here. Alright, doesn't have to be perfect. It's just a quick sketch of a number line is all we need. We really don't need all the numbers in between. Okay, so now these endpoints, are they going to be open circles or closed circles? They're going to be open circles because it's greater than. Okay, so let's use open circles. Your teacher will probably want you to put your circles right on the line, but except for if you're in Burton's class, please go ahead and put your circles above the line so I can see what you're doing better. Okay, but you do what your teacher does. So I'm going to use open circles. If this had been greater than or equal to, then I would have used filled in circles. Okay. Now with these x-intercepts, these zeros, we have divided the number line into 3 zones. Okay, we have a zone to the left, we have a zone in the middle, and we have a zone on the right. Okay, we have 3 zones. So what we need to do is pick a test value in each one of these zones. So I like to organize my work sort of like this. Okay, and make a little chart out of it. Alright, just keeps me organized. So I need a test value in each one of these zones to see if these are solutions or not. So I need something less than negative 1. For example, I could just go with x equals negative 2. I need something in the blue zone. Well, I see 0 there. I always use 0, whatever zone that's in. Okay, and I need something in the pink zone, something bigger than 3. So I'm going to use x equals 4. Alright, anything in the zone would be fine. I could have used x equals 1 in the blue zone, or 2 if I wanted to, or I could have used 5 or 6, whatever you want. Okay, but I'm going to use these values. Now, I'm going to substitute these values back into the original equation, except I like to use the factored form. Is that going to confuse you? Yeah, I'm going to do it the way I like to do it. I like to use the factored form when I substitute. It just seems simpler to me. So I'm going to do the x minus 3 times x plus 1, and that has to be greater than 0. So I'm going to do that for all of these. Okay, so I'm going to substitute my test value of negative 2 in for these x's. Alright, but just to emphasize it, I'm going to use a different color. Okay, so here comes my negative 2. Alright, I'm just substituting in. Now, negative 2 minus 3 is negative 5. And negative 2 plus 1 is negative 1. Okay, a negative times a negative is a positive. And then we ask ourselves, is 5 greater than 0? Well, yes, 5 is greater than 0. That means x equals negative 2 is a solution to the inequality. That means all of these values in this yellow zone are solutions to the inequality. So we will show that these values are solutions by drawing this arrow. So everything less than 1 is a solution. So I'll draw an arrow going to the left to show that these are all solutions. Okay, now let's test the middle zone. Okay, x equals 0. So let me just set up so I can use purple. So I'm substituting 0 for these x's. So that's negative 3 times 1, and that's negative 3. And we ask ourselves, is negative 3 greater than 0? No, negative numbers are less than 0, not greater than. Boo! So that means x equals 0 is not a solution. That means that none of these values in the blue zone are solutions. So we will just leave this empty, and we will move on to the pink zone. And one more time, we will substitute this test value in for these x's. Okay, so test value of 4. So 4 minus 3 is 1. 4 plus 1 is 5. Okay, so 1 times 5 is 5. So, and then we ask ourselves, is 5 greater than 0? Well, of course it is. That means x equals 4 is a solution to the inequality. That means all of the values in this zone are solutions to the inequality. And we will show that everything greater than 3 is a solution by putting an arrow. Oh, that was a horrible arrow. Okay, brilliant. Okay, so this is the graph of the inequality. All right, these are the solutions to the inequality. But we also need to write this as an interval. Okay, we need to write the solution, not just the graph. So we will have we'll have to write this in two pieces, one for each branch here. So over here, this is coming in from negative infinity to negative 1. All right, and we will use round parentheses to show that the negative 1 is not included. Okay, negative 1 is where the parabola is equal to 0. We want to know where the function is greater than 0. So we're not going to include the negative 1. Okay, and then we'll need an interval for this part of the solution set, and that will go from 3 to positive infinity. Again, round, because we're not including the endpoints. Okay, and we will have to use a union symbol to show that we want to include both of these as together as part of the solution set. Okay, so this would be the solution, and of course this is the graph. Okay, so that is it for problem number 2. Alright, and I think I'll just let this be its own video as well. So on the next video I will do another example where we have greater than or equal to. So we'll take a look at number 3.